Okay, for this video, we'll be doing 2023 Pure Physics FTE Paper 1. Okay, the table below lists the physical quantities with their corresponding units. Which unit on the list does not match its physical quantity? So for work done, it's actually Joule, so it's correct. So for pressure, it is Newton per cm square, and this is correct as well. But this is not the SI unit, so it can either be Newton per meter square or Pascal if they were to ask for SI unit. Okay, but Newton per cm square is actually the unit for pressure. It is okay. I'll go through force. Force is actually F equals ma. Okay, then it is a derived quantity because it is made out of mass times acceleration. So the unit for mass is kg. The unit for acceleration is meter per second square. And do we have this? Yes, we have this. Now power, they say is Newton seconds. Okay, so how do we get this? Power equals to energy over time, right? Power equals to energy over time, or it is equals to F times V, right? If it is a constant velocity. But the unit for F is Newton because we want to see if we can get Newton. V is meter per second. So it is not correct. So answer is D because they want something that does not match. Okay, so what's the order of magnitude of the diameter of a human hair? For me, actually, I don't really memorize. So this one you have to guess or you read from your notes. Then you try to memorize. But one thing I would like to point out is for prefix. This is actually 10 to the power of minus 9. You need to know all this. This is micro. This is 10 to the power of minus 6. 10 to the power of minus 6. And C is 10 to the power of minus 2. Okay, so you need to know the value of prefixes. And do you know how to change from prefix to no prefix? So you actually have to multiply by the value of the prefix. Multiply by value of prefix. So that means you need to know all your prefixes. Okay, so you have kilo, mega, and giga, and tera. So this is the 10 to the power of 3, 10 to the power of 6, 10 to the power of 9, and 10 to the power of 12. And we have on the other side the milli, 10 to the power of minus 3, micro 10 to the power of minus 6, nano 10 to the power of minus 9. Okay, so you need to memorize this, and then if they want you to convert from prefix to no prefix, you multiply by the value of prefix. Okay, so answer for this is actually C. Okay, a student has been asked to calculate the volume of a piece of wire which is 0.900 meters long and about 0.150 cm. So you might ask, why don't they put it as 0.9 meters and 0.15? Because they are actually testing you on the precision. Okay, so for the lengthwise, how do I get 0.900 meters? So we may want to write down the precision of meter rule. Meter rule is actually 0.1 cm or 0.001 meters. So is it possible that we get this precision using meter rule? Yes. Okay, so meter rule, yes, for the length. Okay, 0.15 cm. So how about the digital micrometer? What is the precision? The precision for digital micrometer is 0.01 mm. Okay, which is 0.001 cm, which is 0.00001 meters. Okay, so based on that 0.001 cm, I know that it is possible to be digital micrometer. Okay, how about digital calipers? What's the precision? The precision is actually 0.1 mm, which is equivalent to 0.01 cm. So you see it's only 2 dp, whereas over here is 3 dp, 0.150, 1, 2, 3 dp. But we can only get up to 2 dp of precision for digital calipers. Therefore, the answer is A. Okay, that means you need to know the precision of all these measuring instruments. Now, which rule contains only vector quantities? Vector quantities means have magnitude and direction. Okay, whereas for scalar, it is only magnitude. All right. Okay, so vector, this is vector, work done is scalar, pressure is scalar, energy scalar, acceleration vector, time scalar, velocity vector, force vector, mass scalar, acceleration vector, force vector, displacement vector. So answer is D. So you might want to make a list of vector and scalar quantity and to memorize it. Okay, you also need to know what are the base quantities and also the derived quantities. Okay. Now, question 5, two forces act in the plane of this arrow, of this paper, sorry. The magnitude and direction of the two forces are shown below. The two forces are added together. Which diagram shows the correct resultant? That means I need to put them in tip to tail, okay? So, if this is the start and this is the end, right, then this will be the resultant, okay? So, the best answer will be A, okay? A student uses a ticker tape to investigate the movement of a trolley. Ticker tape produces one dot for every 0.02 seconds. That means from this dot X to this one, to this next dot, it takes 0.02 seconds and so on and so forth. So what's the distance between X and Y marked on the tape given that the trolley moves with an average speed of 0.070 meter per second? Okay, so for ticker tape timer, it is important to count the gaps, not the dots. Okay, so from X to Y, we have 1, 2, 3, 4, 5, 6, 7, 8. And in order to make 8 gaps, okay, for one gap, it takes 0.02 seconds. So 8 gaps, I will need 0.02 multiplied by 8, which is 0.16 seconds. Okay, and distance equals to speed times time, so 0.07 multiplied by 0.16, I will get 0.0112. So answer is A. Okay, so for ticker tape timer, count the gaps. They can also sometimes ask you about lamp posts. You know lamp posts? Okay, so again, lamp posts, instead of using gaps, instead of using dots, they can also use lamp posts. So again, count the gaps between the lamp posts. Okay, a ball is released from a height as shown. The scale marking on the left corresponds to the distance that the ball has fallen. Given that the acceleration of free fall is 10 meters per second square and that there is negligible air resistance, that means it is only weight acting on it, right? So the acceleration is going to be 10. Determine the time taken for it to reach the 2-meter mark. So there's distance traveled. We don't know the time, so this one, very standard, you draw your VT graph. Initial speed is 0. After 1 second, the speed is going to be 10. 2 seconds, the speed is going to be 20. Okay, but how long did it take to fall? I wouldn't know. But I do know that at a certain time t, let's say this is t, okay, I know that the speed is going to be at 10t, right? Because every second, the speed is going to increase by 10. Okay, so 1 second, the speed is going to be 10. 2 seconds, the speed is going to be 20. But how about t seconds? Then it's going to be 10t. You see the pattern here? Okay, and then we know that the area under the graph is 2 meters. So basically for VT graph is very useful. The gradient represents acceleration, which we have already used for 10 meters per second square because it's constant acceleration. The next thing that is going to be used is the area under the graph is the distance traveled. And in this question, they give us is 2 meters. It fell from 0 meter to 2 meters, so the distance traveled is 2 meters, which is area under the graph. So it looks like a triangle. So area under the graph is 2 meters, is half times t times 10t, right? Because I try to find the time taken for it to fall. So I get 2 equals to 5t squared. That means my t is going to be square root 0.4. So I don't have my calculator here, but I believe the answer is D. Okay, t equals to square root 0.4. Please check your answer. Let me know if it's incorrect. Now, a paratrooper jumps out of a plane at high altitude, which our following represents a speed time graph from the instant he jumps out. to the instant before the parachute opens. So of course A is not correct, because when he jumps out, the speed is 0. So it's either B, C, or D. Okay, and because it's at high altitude, that means there's going to be air resistance, right? So if there's going to be air resistance, and air resistance is just going to be increasing as he continues to fall, because air resistance increases as speed increases, right? Increase as speed increases. Okay, so that means his acceleration, his F net, is going to decrease. If his F net decrease, that means his acceleration decreases. Okay, but does it mean he's slowing down? If acceleration decrease, it means that he is accelerating at a decreasing rate. Okay, now come back to here. Speed time gradient represents acceleration. Okay, so his acceleration is going to be decreasing, right? That means my gradient is going to be a decreasing gradient. So it's going to be from steep to gentle. Okay, so for C is constant gradient. That means constant acceleration. But no, I'm looking for decreasing acceleration. For D, it is gentle to steep. So it is increasing gradient. For B, it is steep to gentle. So answer will be B. Okay, 10C, a ball is thrown through the air. The ball experiences a small amount of drag compared to its weight. At a particular time, the ball is at point X. Which arrow best represents the direction of the resultant force on the ball when it is at X? Okay, so when it's thrown through the air, right, I expect the ball to fly this way. The ball is going to have a trajectory in this direction. Yes, but there's not going to be any force in this direction. There's no longer a force in this direction, because when you throw out the ball, your hand doesn't follow it to continuously exert a force. Am I right? So actually, if you want the ball to be thrown very far, your throwing force at the beginning must be very high, must be large, right? Because your force from your hand doesn't follow it through. Okay, once the ball leaves your hand no longer exerts a force. So what are the forces actually acting on the ball? Confirm there is one called weight, right? And they tell us that the ball experiences a small amount of drag compared to its weight. That means if the ball is going this way, in this direction, the drag is going to be in this direction, right? Because of the air resistance. Therefore, the resultant force is going to be B, right? Why? Let's do tip to tail. So I shift this here, and this will be my resultant force, which is looking like B. Okay. Now, student A and B engage in a tug of war. Student A wins the game and student B falls forward. Which of the following statement is correct? Force exerted by A on B is larger than that exerted by B on A. This is true, right? The force exerted by A on B is larger than that exerted by B on A. Okay? So this is our Newton's third law, right? So A on B should be equals to B on A. So this is not larger, right? Frictional forces exerted by a ground on both students are the same. May not be. Okay. The force exerted by student A on B is larger than the frictional force exerted by the ground on B. So because B loses, right? So actually A, so you see, A pulls B and B also pulls A. But why is it that A will win? Because the frictional force is not able, you know, when they do tug of war, their feet are always rubbing against the floor, right? So the result is the force exerted by A on B is actually larger than the frictional force on student B. Okay? Okay, so answer is actually C. Okay, a locomotive of mass 50,000 kg is pulling a freight car of mass 10,000 kg. So their total mass is 60,000, yeah. When the locomotive exerts a forward thrust of 10,000 Newton, the locomotive and freight car moves at a constant velocity. When you see constant velocity, it means there is no acceleration. That means no F net. Okay, that means the frictional force or the opposing force is equals to 10,000 Newton. Okay, so this is actually 10,000 initially, and the frictional force or opposing force is also 10,000 Newton. That's why they have no acceleration, no F net, then it moves with a constant velocity. Now, what is the forward thrust required? That means what is this force required? If I now want it to move with an constant acceleration of 0.5, that means now there's going to be acceleration. If there's going to be acceleration, F net equals to ma, I should use the total mass, right? Because it is now considered as a one whole body. The acceleration is 0.5. That means the F net is going to be 30,000 Newton. Okay, so in order to have 30,000 Newton, I already have 10,000 Newton, right? I already have 10,000. Therefore, now I will need 40,000, right? So let me draw the free body diagram. Let's say the frictional force doesn't change. It is 10,000 Newton, all right? And I calculated that my F net is to be 30,000. How do I get 30,000? Because I want the acceleration to be 0.5 meter per second square. So F net equals ma, and I need to multiply by 60,000 because that's the total mass. So if I want F net to be 30,000, my forward force must now increase to 40,000. Because 40,000 versus 10,000, then it will give me F net of 30,000. So it is very important to draw your free body diagram. Okay, question 12. Two forces act on an object in the same plane. Which diagram shows the object having both a resultant force and a resultant moment? Okay, so for A, there is actually no resultant force, right? Because they are equal and opposite to each other. But is there a resultant moment? Yes. No F net, M net, yes, right? Because this is going to be clockwise. This is also going to be clockwise. How about B leh? 20 and 10, so there's F net of 10 Newton. Okay, but because let's say this is sort of the center, then there's no M net is 0. Okay, so there's resultant force F net. How about this? There's going to be F net of 20 Newton. But because this is, let's say, the center, so it's going to be clockwise. This is going to generate a anti-clockwise. So therefore, M net is 0. Okay, how about this? 20 Newton upwards, 10 Newton downwards. So the F net is 10 Newton upwards. So this is going to be a anti-clockwise moment. This is going to be anti-clockwise moment as well. So there's both F net and net moment. So answer is D. Okay, question 13. A load of 9 Newton is placed. Length of the rod is 36 cm. So from here to here is 24 cm. What are the readings? Okay, so this is 9 Newton. That means FP plus FQ must be equals to 9 Newton because it is suspended, right? It is not moving. So the resultant force F net must be 0. Downward force is 9 Newton. So FP and FQ, you add them up, must be equals to 9 Newton. Okay, so this one is actually having two support at P and Q. So we choose one of them to be the pivot. You can either choose P or Q. And I'm guessing most of you will choose P. So I'm going to choose Q. I choose Q as the pivot. Okay, so that's the first step. Second step, how many forces are there? There are 3 forces. FP, FQ, and 9 Newton. Then perpendicular distance of FP to the pivot is 36 cm. For FQ, it is 0. For 9 Newton, it is 24 cm. So now we calculate moment. Fp multiplied by 36 cm, and it's going to be clockwise. Now this 9 Newton times 24 is going to be an anti-clockwise, right? Anti-clockwise, yeah. And because it's balanced, therefore I can apply principle of moment, so I will get Fp to be equals to 6 Newton. Okay, so answer will be C, and you find that they add up actually all to be 9 Newton. Okay, so this one is also add up to be 9 Newton, add up to be 9 Newton. D confirm is out, because like that means there'll be a upward resultant force. So answer is C. Okay, it shows a horseshoe cut from a uniform piece of cardboard. Where's the center of gravity? Now, if I were to divide half, okay, we'll find that this top part has more material, right? So it cannot be at C. Okay, it should be somewhere at B. Okay, my drawing I messed up already. Okay, so why not at C? Because if I were to cut it at C, you'll find that I only have this amount of material there, right? And on top, I actually have more material, right? So it must be somewhere at B. So answer is B. Cannot be at A, because that means this part, which is the center of gravity, I will have, yeah, I think you can sort of figure it out yourself. Okay, so 4 wooden blocks are placed on a plank. The end of plank B is then slowly raised. If they do not slip, which one will be the first to topple? Okay, so the thing here is which, for it to be not toppling, then the line of action of weight must be within base area. Okay, so if I want the line of action of the weight to be within base area, that means the CG must be as low as possible. So this is actually your conditions for stability: CG as low as possible and the base area as large as possible. Okay, must be as large as possible. So for A, the CG is somewhere here, center, right? B is higher. They have the same base area, therefore B is wrong. It will topple more than A. Okay, how about C? C is actually center, D center, right? So the first one to topple over will definitely be B. Okay, because if we look at C and D, they have very big base area, and their center of gravity is relatively lower, or actually the same as B. For C, if I compare B and C, they have the same height of your CG, but C will actually have a larger base area, so C will be more stable than B. Then if I were to compare B with A, same base area, but A has a lower center of gravity, so B will surely topple. So answer is B. Okay, 20 grams of water and 15 grams of substance are mixed together in a beaker. The density of the mixture is 1.2. So they tell us this is the density of the mixture. Given that the density of water is 1.0, calculate density of substance X. So now, average density or density of mixture is the total mass over total volume. Okay, so if I have density given as 1.2, because that's for the mixture, how about the total mass? Total mass is 20 grams plus 15 grams, right? But how about the total volume? Total volume, I only know that the volume of water, density equals mass over volume. I only know the volume to be 20 cm cube for water, but volume for X I don't know. So I'm going to solve this. 1.2 equals to 35 over Vx plus 20. Okay, therefore my Vx I can calculate it out to be, give me a second, Vx is going to be 9.17, okay, cm cube. So they want us to calculate the density of substance X. So then we apply into this formula. The mass of substance X is 15 divided by its volume 9.17. I will get 1.636, which the best answer is C. Okay, so question 16, answer is C. Okay, question 17, it shows a hydraulic system is used to raise a car of unknown mass. What's the maximum mass of the car? They're asking for mass. Over here is given as weight or force. So W equals to mg. Okay, sorry, I think I messed up. Okay, they are asking for mass. So W equals to mg. Later we have to apply this. Now, over here is 100 cm squared. This is 4 meters squared. So they give us the cross-sectional area, but they give it in different units. Okay, so another trick that we can do is they give the radius. Okay, I've already warned you about radius pi r square, right? So if it's 1 cm radius, the area is 1 cm square. But if the radius is 4 cm, the area is going to be 16 times, right? Pi, yes? So it's going to be 16 times larger. So if it's greater by 4 times for the radius, the area is going to be 16 times larger. But now, there's no such trick, but they give us in 100 cm square and 4 meters square. Okay, so we have to actually convert either 100 cm square to meter square or 4 meters square to cm square. So, you know that 1 meter equals to 100 cm. That means 1 meter square is going to be 100 times 100 cm. So I'll get 10000 meter square. That means this is going to be 40000 cm square. Sorry, should be cm square. Okay, so then the units are the same, so it's fairer. So for hydraulic system, the pressure exerted is same throughout. So pressure 1 equals to pressure 2. That means force 1 is over area 1 equals to force 2 over area 2. So my force 1 is 100. The area is 100. Force 2, I don't know. I'm supposed to find. The area is 400. Or, yeah, 40,000. So F2 is going to be 40000 newtons. Okay, and since this is equals to the weight and W equals to mg, that means 40000 newton equals to the mass multiplied by gravitational field strength. That means the mass is going to be 4000 kg. Okay, so answer is C. So 17, answer is C. The trick here is they didn't give us the area in the same kind of units for comparison. Okay, and they want us to find the mass, so you have to go through one more step. After you found the force, which is the weight, you have to convert it to mass. Okay, so this one quite tricky, yeah. Okay, so 18, two identical fish tanks are filled to the same level with water. One tank contains fresh water, the other tank contains seawater, which is more dense than fresh water. Which one experiences the greatest pressure? So of course the one at the bottom will experience the greater pressure. That means A and B are out already. Okay, A and B are out. Then they are at the same height. Okay, they have the same G, and seawater have a larger density, right? So pressure equals to rho GH. So because it has a larger density, it's being placed in a medium of higher density, and they have the same G, same height, but larger density for D, therefore D will experience larger pressure. Okay, next. Diagram below shows a barometer, so if they never say anything, that means it is an ideal one, and indeed we have vacuum, so we do not need to draw arrows. Atmospheric pressure is 750 mmHg, so every time there is pressure, you have to draw arrows and indicate if you know what is it. Density is 13.6 gram per cm cube. Density of liquid X is 3/4 that of mercury. Okay, so they want us to calculate H, the height of liquid X. Okay, so this one is tricky. So where do we have same liquid, same level, same pressure? So it's over here. That means over here on the outside of the tube is 750 mmHg. In the inside of the tube is also at this point also equal to 750 mmHg because same liquid, same level, same pressure. Okay, that means the pressure over here is caused by 600 mm of mercury plus HMM of liquid X. So I will form an equation. 700 mm Hg for the outside is equals to 600 mm Hg, right? Plus H supposedly to be in mm. And how much is that? I'm supposed to have G, and I'm supposed to have density of the liquid X. Okay, so actually if I were to just make it simpler now, I will have 150 mm Hg equals to H of liquid X, G, and density of X. Okay, maybe the way that I write this is a bit confusing. So Hx, then multiplied by G, then multiplied by density of X. Now this is 150 mm Hg. You notice that there is height involved, 150 mm. You have the density of Hg, but where's the G? So this is actually equals to 150 mm times Hg, which is density of Hg, right? And G equals to Hx, G, density of X. And since G appears on both sides, I can cancel away the G. Okay, so I have 150 mm, and density of Hg is 13.6. Okay, so because I'm comparing both sides, I just leave it as 13.6, because if I have my density of X as in gram per cm cube, then my Hx is going also to be in mm, so doesn't matter. So I don't want to spend time to convert it to K, to kg per meter cube, or convert this to cm. Okay, we just leave it as it is, because now it is comparing left hand side and right hand side. So Hx is still unknown, but now I know that density of X is 3/4 that. So this is actually 3/4 times 13.6. Am I right? Okay, 3/4 of that. And we find that I can cancel my 13.6. Then I'm left with 3/4. So Hx, okay, is equals to 150 times 4 over 3. Okay, I'm doing the math very quickly. So answer will be C. 19 is C. Yes. Okay. So this question is quite tough because they, first of all, you need to know the basic, which is whenever there's pressure, you need to draw your arrows. You need to assign what is the value of the pressure, and then you need to apply your same liquid, same level, same pressure at this point here. You need to form an equation then. Okay, so this is for the outside of this, 750 mmHg, and this is for inside the tube. And inside the tube, the pressure is caused by 600 mm worth of liquid mercury plus HMM worth of liquid X. Okay, then you will have to slowly solve it. Okay. Question 20, a block slides from rest down a smooth inclined plane. That means there's no friction. Okay. So which graph correctly describes how the energy in its kinetic store, EK, varies with time? So slides from rest. Okay. So initially the speed is 0, right? Initial speed is 0. That means the KE is 0 at the start. So it should be like that. Okay, so all correct. Then when it slides down, KE's formula is half mv square. Okay, so you see that the KE actually depends on the speed because the mass is going to be the same, but the speed is going to change. And you know that the speed is actually squared. That means it's going to be a quadratic equation, right? You all are math students, so you all should know a quadratic equation. So answer should be C. It's going to increase exponentially, right? So if you have y equals to ax squared plus bx plus c, right, you are going to have this kind of graph. Okay, so the kinetic energy is just going to increase exponentially, not linearly. Okay, so answer is C. Now, stone of weight 100 Newton, so this is W, or force, is thrown vertically upwards from the ground with an initial energy of 160 joules in its kinetic store. So, assuming negligible air resistance, which of following is correct when the stone reaches a height of 1 meters above the ground? So, with this weight of 100 Newton, I can know the mass to be 10 kg, right? Because using W equals to mg, 100 equals to m, the g is going to be 10, so mass is going to be 10 kg. Okay, so when it's 1 meter above the ground, that means there's going to be an increase of mgh, which is 10 times 10 times height of 1 equals to 100 joules, right? So at the start, I only have Ke of 160 joules. GPE is going to be 0 joules, right? That's the total energy, 160 joules. But at a height of 1 meters above, the GPE is now having 100 joules. That means the Ke is going to be left with 60 joules. So remaining 60, 60, 60. Energy gain in GPE 100. Energy gain in internal store is 0. Why? Because there is no air resistance. Okay, so answer is B. Okay, 22. How much work is done in stacking them one on top of the other? So this one, there's a trick lah. Basically, I need to stack this on top. This one remains. Okay, so I don't need to use energy. I need to bring this up by a height of h. So for this, it will be mgh. Okay, once this is on top, I need to stack the third one on top. So it will go through 2h. 2h, right? So it will be mg 2h. So once the third one is on top, I will need to go up against 3h. So this one, the last one, it has to be mg 3h. So h, h, 2h, 3h, so it will be 6 mgh. So 22 answer is B. Okay, so it's estimated that 7,000 kg, which is the mass, pours over the Niagara Falls every second. So every second is 7,000 kg. If the falls are 50 meters high, so that's the h. And if all the energy could be harnessed, what is the available power? So what can we find from here? We have m, we have g, we have h. We can actually find out what is the energy that the falling water have in its kinetic store when it's dropped from a height of 50 meters. Okay, so the mass is 7,000, right? And I take note, it is 7,000 every second, you know. 7,000 kg every second is multiplied by 10, which is the g, multiplied by the height of 50 meters. Just take note that everything is in SI unit, because I want your energy chapter, every unit, every physics quantity must be SI unit. So there we have it. We have 7,000. Let me calculate. 7,000 times 10 times 50. I will have 350,000 joules every second, because they tell me 7,000 kg for every second. So joules per second is actually your watt. So it's your 1, 2, 3, 4, 5, 6. So it will be 3.5 megawatts. Okay, but they give me in kilowatts, so it is 3.5 times 10 to the power of 3 kilowatts. So answer is C. Okay, so you need to know your prefixes. Student observes the Brownian motion of smoke particles in air with microscope. She sees moving points of light due to the smoke particles. So moving randomly. Answer is C. Okay, vibrate is only for solid particles, but in this case, these smoke particles, they are moving in air, and air particles they are moving, they are invisible, you can't see them, they are moving randomly, so they keep knocking them about, so they won't vibrate in place. Okay, for the smoke particles, the mass is small. Okay, and the mass is small, and they can be seen. Okay, so for air particles, we cannot see them. A gas is heated in a sealed container, temperature increase, right? So Ke increase. Which of following does not increase? Average kinetic energy does not increase. No, it increases. increase. Frequency of collision increase because they move faster, right? The average force exerted increase, and the average distance, it does not increase. So answer is A. Why? Because it's a sealed container. The container, we take it that it does not expand. Okay, so no matter how the gas particles move fast, they cannot make the container become bigger. So the average distance between the gas particles will still remain the same. Okay. Okay, 26, a balloon is squeezed, so the volume is decreased and the pressure inside increase. So if you know this PV equals to T, right? So temperature should remain constant, the volume decreases, therefore pressure increase. If there's no change in temperature, so you can actually use this formula. Okay, the particles of air cause this increase in pressure because since temperature remains the same, that means the speed remains the same, because KE remains the same. So the frequency of collision due to the temperature increase, no change in temperature, by right it should be the same. The speed, the force of collision also is the same. But why do they experience an increase in pressure? Because of they collide more frequently with the walls of the balloon. So answer is C. Okay, the pressure on a container, air pressure in a container is due to the force of collision on inner walls and not in between the particles. So please think of that. Because D, although it says also more frequently, but it's with the other air particles, and that does not contribute to the air pressure. Okay, 27, which of following can explain why a metal railing feels colder than a plastic in the same room? So by right, they should be the same temperature lah. Metal is a good thermal conductor. This is true, right? So it will take thermal energy from you at a much faster rate. Energy in the internal state of the metal railing is less than that. That is false. Okay, temperature of the metal railing is lower. That is false also. So answer is A. Okay. Convection occurs in a fluid due to change in density of the fluid. So answer is A. So expansion of molecules, take note. Molecules will never increase in size one. Okay, it's only the space between the particles. Only the space between the molecules that will increase or decrease. Okay, so if I say fluid expand, it means the space between particles increase and not particle size increase. Not particle size. So particle size is always the same. So take note. Okay, 29, a plastic cup is being placed inside another cup separated by styrofoam. Beads between them to make space for a small air gap. So air, you read, then you know it's a poor conductor. Okay, poor thermal conductor. So hot water is then poured into the inner cup and a lid is put on. Lid prevents evaporation, stops the effect of convection. Which statement is correct? Energy lost by radiation is prevented by the small air gap. False, because radiation can even pass through vacuum. No energy is transferred through the sides of either cup. This is false as well. The bench gains energy by convection from the bottom of the outer cup. From the outer cup, this is false, right? Because convection, if it's hot, then it will rise, right? The lid is used to reduce energy loss by convection, so answer is true. 29 is D. Piece of aluminum foil is used to wrap around food to be cooked in a barbecue. Foil has a shiny side and a dull side. Which side of the foil should be on the outside to prevent overheating of the food, and why? So this is so where is it hotter? Okay, where is it hotter? So if it's barbecue, then of course the surrounding, the charcoal, okay, charcoal, all that is hot, right? So if I put let's say my my food here, okay, so it's wrapped in a shiny foil, okay, aluminum foil. So I want to prevent it from being overheated. So I should have the shiny side on the outside because it's a better reflector of radiation. So it will not be absorbing that much thermal energy. But if I'm having dull on the outside, and dull is a good absorber, right? Because now the charcoal hot, so it will absorb thermal energy by radiation. So if I have dull, then it will absorb a lot, much better than the shiny. so then my food will be overcooked. Okay, overheating. So answer should be C. Okay. Okay, so that's the end of the paper. All the best to y'all. Bring your calculator, pencil, and eraser.